Hello, and welcome to Tanner's Poison Emporium, where we have all the latest and greatest poisons to meet your every need. How can I help you today, Mr. Hitman? Hello. I need a strong poison to finally take out a rival scientist. He's been stealing all of my ideas and data, and I've had enough of it. Well, sir, you have come to the right place. Did you have anything already in mind? Well, I was watching Breaking Bad on TV yesterday, and Walter White used this thing called ricin. Ricin? No. That will not do it all. Let me show you the newest shipment of the neurotoxin Abrin. This will do the trick for you. Much more potent than that amateur R crap that sounds like a meal you could get from the walk. Abrin is guaranteed to lead to a painful death and leave no trace of your foul act. That sounds great. Where does it come from? I'm glad that you asked. Like many poisonous proteins, Abrin is found in a plant, specifically the rosary pea. Or, by my favorite name, a much cooler, the crab's eye creeper. It's local to tropical areas such as the Caribbean islands and Hawaii, but this deadly protein knows nothing about Caribbean time. Its effects will never be late. By blocking protein synthesis within cells, Abrin kills off cells one at a time, which can lead to a painful death within 72 hours, much quicker than the lethal time for ricin. Just what I need. I'm interested to see how the toxin actually works. How does it inhibit ribosome? Luckily, I have a video prepared for that exact question. Let's watch this short clip. Abrin is a glycoprotein that can enter the cell and block protein synthesis by inhibiting the eukaryotic ribosome without the need for any additional cofactors. It's composed of two subunits, the A subunit or effectomer shown here on the right, and the B subunit or the haptomer shown here on the left. The B subunit is glycolylated, as you can see here with the carbon skeleton, and the two subunits are joined by two disulfide bonds shown here and here in blue. Before Abrin can inhibit protein synthesis, it first has to get into the cell, and that's where this is the B chain, comes in. The glycosylated groups on the B chain are galactose-specific, and they bind to receptors on the cell that are rich in galactose, sialic acid, and N-acetylglucosamine. Although the mechanism of the binding is not fully understood, the goal of the B chain is to bind as quickly as possible so that it can be endocytosed into the cell, which is shown here, which allows the A chain to enter the cytoplasm. Upon endocytosis, the disulfide bonds that hold the two chains together are reduced so that the two chains break apart. The A chain, which is the toxic part of Abrin, can now travel freely to the ribosome, while the B chain stays bound to the receptor. All this takes time, which is why Abrin takes 8 to 10 hours to kill the host upon ingestion. And now for the fun part. The A chain is the toxic subunit of Abrin and inhibits protein synthesis specifically at the 60S ribosome, which is this absolute unit shown here. How, you may ask? Well, Abrin binds to the ribosome in competition with the protein eukaryotic elongation factor 2, or EEF2, shown here. In normal translation, EEF2 catalyzes GTP hydrolysis, which allows for the translocation of the peptidyl RNA from the A site of the 60S subunit to the P site. The binding of Abrin to EEF2 inhibits the GTP from being hydrolyzed. Therefore, the tRNA in the A site cannot be pushed over to the P site. Although the A chain doesn't inhibit formation of the peptide bonds themselves, it doesn't allow the new tRNAs to come into the ribosome, which completely stops protein synthesis altogether. Wow, that's pretty cool. But what effect does all this biochemistry have on the human itself? Remember, I want him to suffer as much as possible. Oh, don't you worry about that, sir. Abrin will be plenty painful. It all depends on the method of application. How do you plan on delivering the dose to your victim? I was thinking I could spike his meal, or I could attack him and inject him with it. Truly violent indeed, sir. Luckily, either of those two would work perfectly. If the scientists ingest the Abrin, they'll develop vomiting, nausea, diarrhea right away. They'll also go into hypovolemic shock due to dehydration because of kidney failure, which would kill them, but really the immediate cause of death is the body's inability to synthesize the proteins. It leads to massive organ failure, hemorrhaging, and all like the major organs, including the liver, spleen, and kidneys, like I had said before, which leads to a painful, slow death, pretty much from the inside out, within 24 hours. In the case of an intramuscular injection, it would be a lot of the same thing, pretty much. Within 10 hours, remember, the Abrin has to get inside the cells first. The muscles and the lymph nodes would be pretty much destroyed because they couldn't synthesize any more proteins. And then, like I said before, the liver, the spleen, and the kidneys stop, which would lead to internal hemorrhaging and pretty much imminent death due to massive organ failure of every single internal organ in the body. So yeah, either way you go, plenty painful for your victim, unfortunately. Or fortunately for you. Exactly what I need. Now, since I am on a budget, how much will a lethal dose cost me? Obviously, the more Abrin you give, the more likely they are to die and the faster they will die. but you can probably get by with a lethal dose, which is about 40 nanograms, a very tiny amount. But because, unfortunately, it's considered a biological weapon in the United States of America, it's heavily mandated, and we could get in a lot of trouble for selling it to you. But so it'll cost you about $10,000, whereas a bottle of ricin, about the same, will cost about $2,000. $10,000? Why wouldn't I just go with the ricin instead, since it's so much cheaper? There are many advantages to using Abrin over using ricin. And to learn more, let's watch this short clip. The advantage of Abrin over ricin stems from the LD50, or the median lethal dose. Abrin at 40 nanograms is much lower than that of ricin, or 100 nanograms. This means you have to give less poison overall to the patient, which means he's much less likely to detect your foul play. This all stems from this graph, which shows Abrin on top and ricin on the bottom, and it compares the percentage of total bound toxin to the concentration of toxin. As you can see, Abrin has a much higher affinity for cells than ricin, which leads to a lower KD for Abrin. Lastly, if the person detects your foul play and administers a competitive inhibitor to, such as lactose, for either of these two poisons, ricin is much worse at staying on the cell than Abrin is. As you can see, the X's represent Abrin and the circles represent ricin. Even with the increase in the concentration of antitoxin, Abrin is much better at staying bound to the cell than ricin is. Overall, Abrin is just much better in general than ricin. Well, sir, you've sold me. I'll take it. Now, do you take credit card?